Okay, let's talk about air pollution. Sometimes people refer to this as smog, air pollution. That would mean smog is smoke plus fog. The problem, however, is that this is not specific enough. So we have to be more specific, and so we uh, talk about specific components, specific compounds like um, carbon monoxide, CO, carbon dioxide, sulfur oxides, nitrogen oxides, particulate matter, PM, VOCs, ozone, and so forth. So, in fact, if some of you might have heard of the National Ambient Air Quality Standards, and we will talk more about these as we go. National Ambient Air Quality Standards. In short, they are called NAAQS, NAAQS. These are regulations set up in the United States to monitor 6 specific pollutants: carbon monoxide, nitrogen oxides, sulfur oxides, ozone, particulate matter, and lead. And particulate matter is further divided into PM2.5 and PM10. So what that means is that the ambient concentrations, meaning the outdoor concentrations of all these 6 have to be below a certain value at all places in the US. And that's the standard value at all places. That's what the law says. At all places in the United States. Okay. So what are the different effects or impacts of air pollution? We know air pollution has a lot of negative impacts, but if we were to just kind of try to list those in a very broad sense, effects or impacts of air pollution. Well, I would suggest that you might want to pause the video and think and jot down some of these effects and see what you can come up with. Okay, here's some of the list. That first is definitely, we know it has health impacts. Air pollution definitely has health impacts. It can be and human health, plant health, animal health. And then there are impacts on the climate. Particulate matter has radiative forcing, which leads to uh, more um, climate change impacts. And then there's also carbon monoxide, methane. There's carbon dioxide and methane. Of course, there are the greenhouse gases, and so there are definite climate impacts. And one quick thing I want to note here, in the list of the NACs, and these 6 are actually known as the criteria pollutants. 6 criteria pollutants. Some of you might have noticed that carbon dioxide is not a part of these 6, and the reason being that carbon dioxide doesn't have direct human health impacts, although it does have serious climate impacts. So we will talk more about these as we go, but just wanted to point that out. And then something very immediate or impacts our visibility. If in Fairbanks, for example, when we have high days of the summer, sometimes we have these days of very poor air quality because of wildfires. We can see the visibility significantly drops. And growing up in New Delhi, India, I've seen that phenomenon there as well. The haze that surrounds, you can't even see the sun clearly sometimes. So it seems like an orange ball of fire rather than these stunning, shining sun that you see. So it has visibility impacts. Air pollution, and then also air pollution impacts. There is material degradation, and we will talk more about these in the next lectures and when we talk about different criteria pollutants separately. So there's some evidence that ozone and other particulate matter, they impact buildings and rubber tires and a lot of monuments. In fact, if you've heard of the Taj Mahal in India, it's in northern India, it's considered one of the wonders and so forth. So that is made up of marble, and at one point, because of particulate matter and acid rain, the marble started eroding. So there were a lot of steps that were taken to make sure that the monument doesn't get impacted. So that's just one example. There are numerous examples of material degradation impacts of air pollution. And then there's that forests and ecosystems can get impacted. So anyway, these are just a few high-level ones that I've listed. I'm sure we can definitely find more if we think about it. Okay. I wanted to touch base a little bit on the topic of the course, which is air pollution management. That's the title of the course, actually. So what does that mean? Well, if I were to define it, that basically means that we are applying or application of science and technology to limit adverse effects of air pollution. Application of science and technology to limit adverse effects of air pollution. One thing I wanted to mention as a tangential thing, when I'm teaching in person, I tend to write a lot on the whiteboard. I write a lot, and I think I've gotten a lot of feedback that it's very helpful for students because it slows me down. And it's not just about when we're discussing concepts. When I'm solving problems, I like to solve problems on the board. So I would suggest you do the same, that when you're watching these videos, do take your time and write down these notes. Even though you have the videos available, I could have just provided you the text, but I am making the effort to write these all down. So I would suggest you have a notebook where you have your detailed notes in a physical notebook or in an electronic notebook. But either way, I do recommend that you maintain a notebook and follow along all these notes that especially the ones that I write down. I recommend you do write those down as well. And when I solve problems, do solve them actively when you look at these videos. Okay, so that's the kind of a very brief definition of air pollution management. We are using science and technology to limit the adverse impacts of air pollution. And in that process, we will be quantifying, engineers and scientists, oops, we like to quantify things. So we quantify, mainly we quantify emissions. We like to quantify the emissions, what's being emitted. Then we look at how they are being transported, whatever is being emitted, how it's being transported, and then how it's being received, or what is the concentration at different receptors. So when we say quantify, that means we measure concentrations, or measure or report concentrations. So a big part of this first week is going to be looking at the different concentration units of measuring air pollution and quantifying them. So we are going to take a little bit deeper dive into that. But before that, we are going to pivot a little bit to look at the history of air pollution and some of the wide-ranging ramifications that we know of air pollution. And then we'll have a separate session dedicated completely to concentrations. Okay, let's talk about the history of air pollution a little bit. Air pollution is not a new problem. It's been around since civilization, since a long time. So here are some historical events. 1307 in London, King Edward I banned the use of coal in lime kilns. Meuse Valley, Belgium. Jump into the 20th century. Meuse Valley, Belgium. They reported 30 deaths because of air pollution. 1948, Donora, Pennsylvania, reported 20 deaths in 14 hours and 6,000 illnesses in 4 days, and out of a population of total 14,000. Then 1952, London, 4,000 deaths in 1 week. That's the London smog of 1952. In 1984, Bhopal, India, this is an example of an industrial air pollution disaster. Union Carbide, now Dow Chemical, there's a chemical plant in India that leaked poisonous methyl isocyanate gas, killing 10,000 people overnight, and many more were disabled for life. These are some of the images from some of these disasters. And the London smog of 1953, 52 December, 53 January, people said it was so thick, the smog was so thick that if you're walking out in the street, you could not see your own shoe. And then this is an epidemiological analysis where they plotted the mortality rate in London Administrative County and the Outer Ring, and almost 4,000 deaths were attributed to the London smog of December, January 1952-53. 4,000 excess deaths. Okay, so now looking at the scale of air pollution issues span several scales. If you look here, there are, of course, very localized urban scale issues: health, asthma, mortality, property damage, visibility reduction, as we discussed, and these are from localized emissions here. And then you can have regional impacts from these emissions. There can be acid deposition, regional haze, leading to forest decline, fish death, reduced crop yield, and regional visibility reduction. So there are regional issues. And uh, more global issues: ozone depletion, global warming, long-range transport of contaminants and air pollutants, and leading to skin cancer. This is due to the ozone layer depletion up in the stratosphere. Then background air quality, the severe weather events, and even species extinction. So there are like global ramifications of air pollution. So it impacts even at a very microscopic household level, if you will. There are like indoor air quality. There's a whole field of indoor air quality not even mentioned here. Um, Looking at some of the impacts, a WHO report mentioned that air pollution kills about 7 million people every year, and it's the largest single environmental health risk. And some people, mention to air pollution as a silent killer, because if somebody dies in a car crash, you can easily attribute that accident as the cause of death. However, air pollution, it's not easy to correlate, draw a one-on-one correlation that because that person was exposed during their lifetime to so and so much quantity of air pollution that they died of a cardiac arrest or they died of cancer. So it's hard to uh, correlate that, and that's why a lot of people uh, find it easy to turn to turn their blind eye toward that, or close their eyes towards air pollution. Um, and outdoor or ambient uh, contribution of the 7 million, about 4.2 million people uh, are attributed to be impacted or killed from stroke and heart disease because of air pollution, and indoor air pollution impacts about 3.8 million people, so almost 50-50, you could say. And also WHO says that air pollution causes cancer, and it added air pollution to its list of carcinogens, uh, in addition to asbestos, benzene, UV radiation, radioactive species. And there were estimates that lung cancer from air pollution is responsible for about 500,000 or more deaths. And there's evidence that air pollution also increases the risk of bladder cancer. Example of indoor air pollution: there's a company called Lumber Liquidators. Um, it was a flooring which was found to contain dangerous levels of formaldehyde, and it was, and then when it was found, the Lumber Liquidators, they suspended the sales of laminate flooring from China. And this is a few years back, but this is an example of like how a lot of our seemingly innocuous, seemingly mundane things that we all interact with, our flooring, our walls, paints, upholstery, furniture, carpet, they all emit a lot of different volatile organic compounds, VOCs. Formaldehyde is a prominent one. And in that instance, it was found that the flooring was compliant with the rules, but contained up to 13 times more than the limit. And then Lumber Liquidator provided air quality test kits to its customers, and 97% of which returned below the WHO guidelines. So just an example of how things can impact. We can have air quality impacts from, we all know the new car smell, right? And a lot of that is also VOCs in there. And talking of climate change, large companies are there. They have a preparation to pay price on carbon. For example, 5 big oil companies, they're assuming price on carbon in long-term financial plans. And the United States has a plan to reduce the carbon emissions uh, by 80% um, to 80% below the 2005 levels by 2050. And other large companies like Microsoft, GE, Google, DuPont, etc., they have carbon footprint and associated costs in their budgetary preparation. So air pollution has industrial ramification and economic ramifications as well. Talking of the Clean Air Act and formation of the US EPA, it was the first federal legislation to actually pertain to controlling air pollution. There were a lot of state legislation before that, but this was the first federal legislation that the Clean Air Act of 1963, and the idea was to protect the environment and public health in the U.S. and to that effect, the EPA was formed in 1970. 60s was the era of the environmental revolution in the U.S., if you will, and the culmination of that was the formation of EPA in the 1970. And believe it or not, the presidential election preceding 1970, environmental uh, environmentalism was, or environmental awareness and environmental revolution was a key part of the presidential campaigns. We briefly talked about the National Ambient Air Quality Standards, so NAAQS. It applies to 6 pollutants, and these are known as the criteria pollutants: particulate matter, ozone, carbon monoxide, nitrogen dioxide, sulfur dioxide, and lead. We are going to be talking a lot more about these in the semester as we go. Um, and but let's look at this impact of Clean Air Act on the cost and benefit. So what are the costs of implementing the Clean Air Act? There are pollution control equipment, cleaner fuels, and the benefits were reduced mortality, reduced illness, reduced lost work days, and better agriculture outputs. And these were the main trouble creators or troublemakers were ozone and PM 2.5. And you can see the benefits. If you put them in dollar terms, the benefits way exceed the costs. So it does make a lot of sense to clean our air and on history and background of air pollution. In the next session, we're going to look at concentration units of air pollutants. Okay, in the next session, so this is a little bit of discussion on history and background of air pollution. In the next session, we're going to look at concentration units of air pollutants.